50 ships. Over 1,000 people. Vanished without a trace in a triangle of ocean that covers 500,000 square miles. For 70 years, the Bermuda Triangle has been called Earth's most dangerous place. But here's what they don't tell you. The U.S. Coast Guard has tracked every single vessel that's crossed these waters since 1950, and the data reveals something shocking. The disappearance rate? Statistically identical to any other patch of ocean on the planet. So if the Bermuda Triangle isn't deadly, why does the myth persist? And what's science actually hiding about what happens in these waters? The legend started with a single article. In 1950, journalist Edward Van Winkle Jones coined the term after noticing a pattern of disappearances. But pattern recognition isn't the same as causation, and when researchers at the University of Southampton analyzed marine incident data from 1840 to 2015, they found something remarkable. The Bermuda Triangle accounts for roughly 0.00012% of maritime incidents worldwide. That's the same rate as the North Atlantic shipping lanes off Ireland, or the Pacific routes between Japan and California. The math is brutal. With 166,000 vessels passing through annually, even a statistically normal accident rate will produce dozens of incidents per year. But here's where it gets interesting. The myth persists because nobody talks about what's actually happening beneath those waters. Scientists at MIT and the Woods Hole Oceanographic Institution have been studying massive methane hydrate deposits on the seafloor. These frozen pockets of gas cover approximately 15,000 cubic kilometers of the ocean floor in the region. When tectonic activity or temperature changes destabilize these deposits, they release methane bubbles that rise to the surface. A 2016 study published in the American Journal of Physics demonstrated that these bubbles reduce water density by up to 40%. Ships lose buoyancy instantly. Within seconds, a vessel can sink without sending a distress signal. The Norwegian University of Science and Technology ran computer simulations showing that methane eruptions create craters up to half a mile wide on the ocean floor. Several of these craters have been mapped in the Bermuda region. Suddenly, disappearances aren't mysterious at all. They're geological events with predictable physics. But methane explains only half the equation. Researchers at the National Oceanic and Atmospheric Administration discovered something else: magnetic anomalies. The Earth's magnetic field isn't uniform. In specific zones within the triangle, compasses can deviate by up to 20 degrees from true north. Before GPS, this would send ships miles off course, directly into shipping lanes or shallow reefs. Flight 19, the most famous disappearance in 1945, involved 5 Avenger torpedo bombers. The flight leader's last transmission? We don't know which way is west. Everything is wrong. We can't be sure of any direction. Even the ocean doesn't look as it should. Magnetic confusion explains navigation failure without invoking the supernatural. And then there's weather. The triangle sits in a convergence zone where the Gulf Stream meets cold northern currents. Meteorologists at Florida State University analyzed 70 years of weather data and found that the region produces microburst storms, sudden downdrafts of air exceeding 100 miles per hour that can appear within minutes. These microbursts are invisible to radar until they hit. Aircraft caught in them experience catastrophic loss of altitude. By the time pilots react, it's too late. The 2003 disappearance of a Piper PA-23 was later attributed to exactly this phenomenon after recovered flight data was analyzed. So why does science hide this? It doesn't. The truth is simply less profitable than mystery. A 1975 study by librarian Lawrence David Cush examined every single documented Bermuda Triangle incident and found that most reports were exaggerated, incorrectly located, or occurred during known storms. Several disappearances never happened at all. The boats were found, or never existed in the first place. But mystery sells books. Mystery gets clicks. Mystery builds legends that outlive facts. Let's talk about what happens when you combine all 3 factors: methane eruptions, magnetic anomalies, and violent weather. Researchers at the University of Alaska ran probability models showing that when these conditions align, which happens approximately 4 to 6 times per year in the region, the risk of catastrophic incident increases by 340%. But here's the critical detail. The same alignment occurs in the North Sea, the Devil's Sea near Japan, and the Great Lakes. Those regions don't have myths because they don't have marketing. The Devil's Sea off the coast of Japan has a documented disappearance rate 15% higher than the Bermuda Triangle, according to maritime insurance data from Lloyd's of London. Between 1952 and 1954, 5 Japanese military vessels vanished there. The Japanese government declared it a danger zone. Yet the Bermuda Triangle dominates global consciousness. Why? Because Charles Berlitz's 1974 book, The Bermuda Triangle, sold over 20 million copies, while equivalent incidents elsewhere got footnotes in maritime journals. The electromagnetic anomalies deserve deeper attention. Physicists at Columbia University discovered that areas with high concentrations of magnetite, a magnetic mineral, create localized distortions in Earth's magnetic field. The Bermuda region has some of the highest magnetite concentrations in the Atlantic due to volcanic activity millions of years ago. This isn't speculation, it's measurable. Submarines routinely compensate for these anomalies using gyroscopic navigation. But surface vessels before the 1980s had no such technology. They relied on magnetic compasses that would point toward the magnetic anomaly instead of magnetic north. The result? Ships traveling in circles, burning fuel, becoming stranded. And the methane theory gained confirmation in 2017 when Russian scientists exploring the Barents Sea found craters identical to those mapped in the Bermuda Triangle. They deployed autonomous underwater vehicles and discovered active methane seeps releasing thousands of cubic meters of gas daily. When they simulated the effect on a scale model ship, buoyancy loss occurred in under 8 seconds. There's no time to react, no time to send an SOS. The vessel simply drops. But the most fascinating revelation comes from satellite data. NASA's Terra satellite, equipped with atmospheric methane sensors, detected periodic methane plumes rising from the exact coordinates where several famous disappearances occurred. The data spans from 2005 to present. The plumes correlate with seismic activity detected by ocean floor sensors. When minor earthquakes occur beneath methane hydrate deposits, the ice structure fractures, releasing gas. It's not constant. It's episodic. Unpredictable. Which perfectly explains why most ships cross safely while a handful vanish. The insurance industry knows this. Lloyd's of London doesn't charge higher premiums for vessels crossing the Bermuda Triangle. If the danger were real and exceptional, actuaries would price it in. But they don't, because 75 years of claims data shows no statistical anomaly. The triangle is as safe, or as dangerous, as any equivalent stretch of ocean with similar traffic density. So here's the real question. If science has explained every disappearance through methane, magnetism, and microbursts, why does the legend persist? Because mystery serves a purpose. It's entertainment. It's identity for a region that markets itself on intrigue. The Bermuda Triangle generates an estimated $40 million annually in tourism revenue. Museums, boat tours, documentaries. Truth doesn't sell tickets. Mystery does. Have you ever believed something so deeply that evidence couldn't shake it? What would it take for you to change your mind about a story you've heard your whole life? Drop your thoughts below. This isn't about proving you wrong. It's about understanding why our brains prefer mystery over math.